In this video, we are going to keep it very simple. You've just learned about 5 different types of reactions that can occur. There's more than 5 different types of chemical reactions, but you've learned about the 5 general chemical reactions that chemists use to broadly classify reactions. And so our learning goal for this video is simple. We're going to identify each of the 5 common chemical reaction types: synthesis, decomposition, double replacement, single replacement, and combustion, given a chemical reaction equation. Let's get to it. Let's review the general formulas and an example of each of our reaction types. First, we have a type of reaction where we have 2 elements or compounds that are separate from each other that come together to form one product. Think about it as A plus B becomes AB. When there's no plus sign, it means that the 2 different compounds or 2 different elements have bonded together to form one bigger compound. So this would be an example of what we call a synthesis reaction. The word synthesis means to create. So I like to think about this as creating one substance out of multiple substances. An example would be hydrogen gas reacts with oxygen gas to form water. So H2 plus O2 reacts to form H2O. 2 different elements react to form one compound, water. Our next example is decomposition. It is the opposite of synthesis, and so I'm using exactly the opposite example here. So instead of taking hydrogen and oxygen and combining them to make water, let's start with water and break that water apart into hydrogen and oxygen gas. So the general formula for a decomposition reaction, you're looking to see if there is only one reactant, only one chemical formula on the left-hand side, no plus signs at all, and more than one chemical formula on the product side. So there should be no plus signs on the reactant side and at least one plus sign on the product side. It's one of the clues that you have a decomposition reaction, a substance breaking apart into its constituent parts. Here's a third example. Take a moment to think about what type of reaction you think this might be based on what we've learned so far. The example that I give here is silver nitrate and sodium chloride react to form silver chloride and sodium nitrate. And the general formula I've got is AX plus BY reacts to form AY plus BX. So this is a double replacement reaction. We start off with 2 compounds with 2 different parts to each compound. AX plus BY. X and Y switch partners, and Y ends up with A, B ends up with X. So in this example, AG starts off with nitrate, silver starts off with nitrate, and ends up with chloride. Sodium starts off with chloride and ends up with nitrate. It's a double replacement reaction. This is different. It is a subtle difference, but it is different from a single replacement reaction. Here's an example of a single replacement reaction. Copper sulfate and aluminum react to form aluminum sulfate and copper. So in this example, notice in the general formula, there is one element that is starting by itself. In this case, aluminum. It is not in a compound. There is one element that is ending by itself, in this case, copper. And copper and aluminum are switching places with each other. Copper starts off in a compound with sulfate. Aluminum ends up in a compound with sulfate. So notice how that's different from this double replacement reaction where both sets of elements have partners. They're all in compounds before and after, versus a single replacement reaction where one element ends up by itself and one element starts by itself. And then finally, our most recent reaction type that you've learned about is combustion. So generally, combustion takes place between a hydrocarbon, so CXHY. I put X and Y there just because they can be any numbers, right? There's lots of different hydrocarbons. Plus oxygen gas reacts to form water and carbon dioxide. When you see water and carbon dioxide as your products, go and check and see if oxygen and carbon, hydrogen are all on your reactant side, you probably have a combustion reaction. This is an example of a combustion reaction here. Propane burns in oxygen to produce carbon dioxide and water. So C3H8 plus O2 reacts to form CO2 plus H2O. Here's a summary of what we just went over with some more visuals. These are some great notes to write down. Writing can really help your mind and your memory to form those connections. So if you want to pause the video right here, here are some great notes to write down. Otherwise, we will go on and do some practice. So pause this video. I would like you to decide for each of these reactions, what type of reaction do we have? So there's 5 options: combustion, synthesis, decomposition, single replacement, or double replacement. So for each reaction, which type do you think it is? Looking at number 1, I notice that I have N2 plus O2 becoming NO3. There is a plus sign on the left-hand side of the equation. There is no plus sign on the right-hand side of the equation. So I have 2 separate elements that are coming together to form one compound. This is a synthesis reaction. I'm going to try not to get too distracted by the subscripts and the coefficients, and just notice that I've got 2 separate formulas coming together to form one formula. Number 2 is the exact opposite of the reaction that we just did. Did you notice that? I've got NO3 becoming N2 plus O2. This is a decomposition reaction, the opposite of putting pieces together to make one new product. Synthesis is taking one substance and breaking it apart to make 2 products. That's decomposition. Think about it when you think about decomposing food. Number 3, PbNO32 plus 2NaCl reacts to form PbCl2 plus 2NaNO3. There's a lot going on here. When I see this many letters in a chemical formula, I'm going to stop and check. Pb ends up with Cl2, Na ends up with NO3. I'm noticing that these formulas are really just partner swapping, right? Pb starts off with NO3 but ends up with Cl. Na starts off with Cl but ends up with NO3. This is a double replacement reaction. It's double because both of the starting substances were in a compound, right? None of them were alone as a single element, and both ended up in a compound. Question number 4. I noticed that the products are CO2 plus H2O. That should set off alarm bells in my head. When the products are CO2 plus H2O, and the reactants are O2 plus some number of carbons and hydrogens, that's going to be a combustion reaction. That is some sort of carbon fuel, in this case it would be butane, burning in the presence of oxygen to form carbon dioxide and water. Question number 5, zinc Zn plus H2SO4 reacts to form ZnSO4 plus H2. So I have zinc starting off by itself, not bonded to anything, and hydrogen ending up by itself, just bonded to itself. So hydrogen and zinc are swapping places. This is going to be a single replacement reaction. Notice how it's different from number 3, how it's different from the double replacement reaction, because zinc is not bonded to any other element, and neither is hydrogen, whereas in the double replacement reaction, there's always another element being bonded together. Number 6, notice how much number 6 looks like number 4? That's not a coincidence, right? CO2 plus H2O is my products, O2 plus some number of carbons, some number of hydrogens. That is a combustion reaction. Question number 7. Hg plus O2 reacts to form 2HgO. So I have 2 separate substances, 2 elements, right? Hg by itself, mercury by itself, plus oxygen by itself, making one compound. This is a synthesis reaction. There's a plus sign on the reactant side, no plus sign on the product side. Number 8, H2CO3 reacts to form CO2 plus H2O. Now this is one place where alarm bells should not go off in your head about the CO2 and H2O. This is not a combustion reaction, even though I know I said that if the products are CO2 and H2O, it usually is. But notice, in this case, the reactants are not some sort of hydrocarbon plus oxygen, right? The reactant, it's just one reactant, is H2CO3. And it's breaking apart to form CO2 plus H2O. This is a decomposition reaction. You start with one compound, and you end up with 2 compounds. So that would be a decomposition reaction. Number 9, 2Ki plus PbNO3 reacts to form PbI2 plus 2KNO3. This is going to be a double replacement reaction. Potassium starts off with iodine, ends up with nitrate. Lead starts off with nitrate, ends up with iodine. Finally, number 10, magnesium plus HCl reacts to form H2 plus MgCl2. So magnesium and hydrogen are swapping. Which of the elements is bonded to chlorine? Magnesium starts off by itself, hydrogen ends up by itself. This is a single replacement reaction. Now we've gone through and we've practiced all 5 reaction types. Way to go! Let's check back in on our learning goal. Very simple, this video. Hopefully you feel more confident in determining what type of chemical reaction you have given a chemical formula. Great job!